In this example, I'll be programming this FPGA with an echo program that will take anything that is received over this USB link from a terminal on the PC, and it will just take it in and then just echo it right back to the terminal. As you can see, there's nothing else hooked up to the FPGA board because there's nothing needed for this example. So building the hardware for this was pretty quick. For the software, first thing we want to do is load the Bitstream into the FPGA, and I already had the Bitstream precompiled, and there it is right there. So I will just drag it to the GXS load window and load it into the FPGA. Okay, that's done. Now, before I can send characters down the USB link, I need to set up a null modem setup. So I'm going to use Comm to do that, and I'm going to add a pair of terminals. There they are. I'm going to rename them to Comm7 and Comm8. Why those names? There's no particular reason. Those are just the names I've kind of gotten into a habit of using. And now I'll just rename those. Okay, they're renamed to Comm7 and Comm8, and I only need to do this once I exit the program, and those Comm7, Comm8 terminals will be linked together, and they'll always be there. Even if I reboot the computer, they'll still be there the next time I boot up. Now I need to get the USB to serial port server running. So I'm going to open up the place where I keep that program, and I'll start a command prompt because I'm going to run this through the command line. And the command is python usb to serial.py. I'm going to run in the debug mode. The COM port I'll be attaching the server to will be the COM port 8, and that means the other COM port 7 will be where I'll attach my terminal to. And the module in the FPGA that does the echoing is at location 255. Get back a couple of prompts from the program since it's in debug mode, and it says it's attached to serial port COM8, and gives you some information about the size of the FIFOs that are down in the FPGA. So that's running. I can close this. Now I have to start a terminal program, in this case PuTTY, and I'm going to set it up as a serial. They connect it to a serial line. I'm going to connect it to COM port 7 because this USB to serial server is on COM port 8, and those two are linked together. Speed doesn't matter, and I just say open. And here's my COM port. Here's my terminal, my PuTTY terminal, and I'll put the server down below that so you can see the debug messages that go through. Now anything I type in here should be echoed back to me, and you can see that I typed the first few letters of the keyboard, QWERTY, and they were echoed back to the terminal window, and the debug messages came flying through here. If I type the characters 1, 2, 3, which have ASCII values 31, 32, 33 in hex, then you can see that we had 31, 32, and 33 that were going through the USB to serial server. So the design that's in the FPGA does seem to be echoing characters from the PuTTY terminal that are sent through the USB link to the FPGA board, and then echoed back from the FPGA board through the USB link and back to the PuTTY terminal. Now you might ask yourself, well, how do we know that you're not fooling us by having the PuTTY terminal in a local feedback mode, local echo? So I'll go ahead and change the settings on the terminal just so you guys will trust me. Local echo is auto, but I'm going to force it on in this case so that everything will be locally echoed, and apply it now. Now when I hit any character, it should be seen twice. So see, Q comes out as QQ. One is the local echo, and the other is the echo coming back from the FPGA. And again, you can see down here in the debug window that it's only sending back one character at a time. It's not sending back two, so it is actually doing the echoing. And that pretty much concludes this demonstration.